Hi all. So in this particular video we look into the collision of elastic bodies. So what do you mean by this particular terminology elastic? First we'll look into that, then we'll start with the topic. So elastic body. So let me say you have a body, you apply a force, it will deform, right? And then once the force is removed, the body regains its original shape. These bodies are referred as elastic bodies. Okay, so the first condition, you apply force, it deforms. You remove this particular force, it regains its original shape. All these bodies will fall under the category of elastic bodies, right? So we'll look into what is that we're going to see in the collision of elastic bodies. So there are certain conditions which you have to assume that will be happening, although again it is just only for the purpose of theoretical understanding. Practically this is merely impossible, because the first point, elastic bodies, none of the bodies or none of any physical parameter or physical phenomena is completely elastic. We have some part of it as a plastic member, which means even after the removal of force will have some amount of deformation. Okay, so that itself is a pure assumption or a theoretical assumption. So under that particular category, the first assumption is the bodies immediately after collision come momentarily to rest. Okay, so let me say that you have two bodies. So A is colliding with B. So A is moving in this direction, B is again moving in this particular direction. It collides. Let me say at this particular colliding position, the time is 0. At this instant, at the point when it is colliding, both the velocity of A and the velocity of B will be equal to 0. So this is their first point. Second point, two bodies tend to compress each other so long as they are compressed to the maximum value. Okay, so this is just a small definition. Because both these bodies are moving with some amount of velocity, obviously they are going to compress each other. Two bodies attempt to regain its original shape due to the elasticity, and this sometimes is also referred as restitution. Okay, so this particular terminology, restitution, we'll be studying in detail when we are solving the problem. But as stated, most of the conditions we are just going to assume that it's going to be a elastic member, right? So this is the formula that will be used for solving the collision of elastic bodies. So law of conservation of momentum states that your momentum before collision is equal to the momentum after your collisions. Okay, so your momentum is basically your mass into velocity. So here again just make a small correction. This is m1 u1, it's not m2 u2, it is m1 u1, right? So m1 and m2, which is present both on the left hand side as well as on the right hand side, corresponds to the mass of the first and the second body respectively. So m1 corresponds to the mass of the first body and m2 corresponds to the mass of the second body. u1 corresponds to the initial velocity of the first body, u2 corresponds to the initial velocity of the second body. So is the condition with v1 and v2. Final velocity of the first body, final velocity of the second body. So if it has to be represented as a figure, first you have two bodies with mass m1 and m2. So this is going to travel with a velocity u1 and mass m2 is going to travel with a velocity of u2. So this is the first condition. Second, both these masses collide with each other. And the third condition, you have mass m1 which is moving away with a velocity v1 and mass m2 which is moving away with the velocity as v2. Okay, so all these three things, 1, 2 and 3 phenomena combined together will be this particular equation, m1 u1 plus m2 u2. This first condition, then it collides, then the third condition, m1 v1 plus m2 v2. Okay, so this particular law of conservation of momentum will be used to solve the problems. So this is what I told in the previous slide also. You have two bodies, mass m1, m2. So it collides m1 and m2, then it leaves with a perfect velocity, final velocity v1 and v2. Okay, so now this particular terminology E comes into picture. This is referred as restitution. What does it mean? When you have a perfectly elastic collision, E is equal to 1. If you substitute E is equal to 1 in this equation, you will be able to find that velocity of separation is equal to velocity of approach, which means there is no loss of velocity, or basically your velocity loss is equal to 0. Whereas if you have a perfectly plastic collision, if I have to tell an example of a plastic collision, you take a clay ball and throw it on a wall. So what happens is, clay obviously is purely plastic. When it touches the surface with some amount of velocity, it sticks on to that particular surface, basically your wall. What happens? Your restitution takes a value of 0, which means all velocities are lost. Please note the point, energy is not lost. This velocity will produce a energy. That energy is actually used up for deformation. Okay, so a law of conservation of energy will be maintained. That particular energy produced because of velocity will be used for deforming that particular body. Okay, but in real time practice, you are not going to have a perfectly elastic nor a perfectly plastic collision. Some value of E will be present. Most importantly, that particular value of E will be lying between 0 and 1, right? So basically what happens, if you look into the equation, your final velocity will have or will be lower than that of your initial velocity or velocity of approach, right? So using these set of formulas, the first one is where you have your law of conservation of momentum, and the second one is where you have this particular formula, v2 minus v1 is equal to v2 minus v1 is equal to E into u1 minus u2. So both these formulas will be used, and then that will be used to solve the problem. Thank you. Hi. So in this particular video, we'll look on to the types of collision. The first type of collision is referred as a direct collision. Okay. So and the second type of collision is called as an indirect collision. So what is the basic difference between a direct collision and an indirect collision, right? So the first thing is your velocity. There are a few things that you have to remember. First one is line of impact. Next is point of contact. Okay. Here again, line of impact is going to exist, right? Obviously, this is your point of contact, right? So what happens in your line of impact? So this particular A obviously will have a mass ma, and this will have a mass mb. Similar to that, you are also prone to have ua, ub and va and vb. So what happens is, your ua, let me just put it as ua. Please don't look into the direction will change, but look on how this is aligned. ua, and let me say that you have ub, and similarly va and vb. So object is called as So if you look into the velocities UA, VA, UB and VB and your line of impact, everything will be parallel to each other. So UA, UB, initial velocity of initial velocity of A, initial velocity of B, VA, VB, final velocity of A, final velocity of B, and your line of impact, all these things will be parallel to each other. Whereas in the case of indirect collision, it's not parallel to each other, as simple as that. So UA, UB, VA, VB and your line of impact will not be parallel. Okay, so this is the difference between your direct collision as well as your indirect collision.